Okay, we're back. Decided to do some testing after we got done with our math and our little test circuit earlier. Put a current measuring device and an amp meter in line with our test circuit. Also have a voltage meter across the LED that we're testing. Let's see if it adds up to the math. I can already tell you it doesn't. And that got me wondering, what's going on here? Do we have a bad LED? I don't think so. It's shining pretty good. Do we got a bad resistor? The wrong resistor? I've already double checked that. We're good there. And we'll check it again here in just a moment. But my current is at 26 milliamps. Same circuit. 120 ohm resistor. Or maybe did Radio Shack write the wrong forward voltage on the sheet? I'm here to tell you. I've seen a lot of diodes. And there's a few of them that are 5 volt out there. Most of them are closer to 3. Depending on the color, depending on the intensity. The typical 5mm LED usually runs around 3 volts. Let's see what happens with our test setup. So here we are with our test setup. Same arrangement as before. Got a couple extra test leads on there so we can do some more testing with our digital multimeters. We're still running 6.3 volts out of the power supply. There's our current running through there. This is where things started getting a little interesting, when I wanted to double check to see if we had 11 milliamps. Now, earlier I was thinking it didn't look quite as bright as it would at full current flow through there. But I think we were just off angle a little bit. That's a bit brighter than it looked like earlier. But we're still at 26.7. And I measured the voltage drop across the LED. We're at 3.1. Not 5, not 4, but 3.1. That's actually a little bit closer to what a typical LED would be. So I'm thinking Radio Shack didn't do us any favors when they put that 5 volts on there. Especially when they listed 30 milliamps with the 5 volt. Now you could probably run 5 volts through it. It'd probably be fine, but I have a feeling you're going to have more than 30 milliamps. Let's see what the voltage drop would be if we were actually running 30 milliamps through this LED. Turning up the power supply, get a little more voltage, and we'll get close to that 30. Ooh, right there. Still only 3.13 volts. So if you're running max current through this LED, you're not going to get 5 volts drop across it. In fact, I think by the time you got 5 volts across that thing, you'd be considerably above 30 milliamps. So I think basically we have wrong specifications written on the package, but that's fine. And even 26 milliamps isn't bad. It's showing, hopefully it's right, 30 milliamps is the max, and that looks pretty good for that LED. But why is that voltage low with the current so much higher? And this is where the other half of the circuit pops in. If I take my 3.1 volts and I divide it by the 26.8, I had a 26.8 millivolt reading earlier, that means the effective resistance of that LED is 115.67 ohms. And that's pretty much going to stay 115.67 ohms no matter where it's at in its operating range, except for maybe right down at the bottom. And of course, if you definitely exceed its forward voltage and its forward current and it blows up, of course that's going to be a lot higher. But it's pretty much going to stay right there through its operating range, which means this LED voltage drop at an appreciable amount of current for it is always going to be right around 3 volts. So I think we're just going to go ahead and stick with the 120 ohm resistor. And we'll take a little closer look at it, and I'll show you if I can get this to focus. That we have, and this is not showing up very well on the camera, but brown, red, brown, and that's supposed to be silver. It's reflecting the blue light, so it looks blue. But that's brown 1, second band red 2, third band times 10, 120. And I did verify that with an ohms meter across it. So we're going to continue on. I'm still happy that we're operating within specifications of 30 milliamps. That's generally acceptable for a light emitting diode. We don't have a lot of room inside of here, so we can't get too creative with resistors. In fact, just to give you an idea, right there, that's the negative side of the current pilot lamp, and just above that is the positive. Get my pencil in here to kind of give you an idea of what size we're looking at here. Get some light on it as well. You might be able to see it, right? There's our negative, there's our positive. And over here is our negative right behind this black wire, and our positive. So we don't got a lot of room in there. So we don't want to take too much space up with resistors. And that's about a 1/4 watt resistor. Don't want to go any smaller than that. We want a little bit of headroom and making sure we're not going to pass too much current through that little resistor, too much power, not even warm to the touch. So I think we'll be fine inside that radio. I'll be back with more updates, probably have a little bit more of the final circuit put together, maybe even installed in the radio. But I wanted to bring this up, that well, sometimes specifications on the back of packages for components sometimes might be a little off. Fortunately, we did go ahead and go with the 120, and it put us close. We were saying 25 milliamps or less. 26.6 now. It's come down just a touch even. It's still going to work, and I think it's still going to look good. So I'll be back when we have more.